All right, and we're back with another episode of Abstract. And in a minute, but this I can assure you is going to be worth the wait. Today, we're diving into a topic that's been bubbling under the surface for a while. That is how wallets are quietly being reimagined from the inside out. Joining us today is Gautam from Silence Labs, who leads growth there and has been right at the center of launching one of the fastest MPC protocols in the space. If you've heard of us around DKLS 23 and 10x signing speeds and verifiable wallet security, this is the team behind it. And from Okto, we have Pulkit, who's been spearheading the rollout of the new decentralized wallet network to over 17 million users globally. Together, their teams have built something powerful wallet infra with three independent MPC nodes, two of three threshold signing, zero centralized custody, and cryptographic guarantees that anyone can verify. In today's episode, we're digging into how it works under the hood, what it unlocks for the users and developers, and why this might be just the default for wallets going forward. Gautam, Pulkit, great to have you both on.
Yeah,
Same here.
thanks for having
Yeah.
having us here, and yeah, really excited for the chat.
All right, so let's go around the room for a quick round of intros.
Cool. Maybe I'll start, right? So, hi, my name is Gautam. I lead the growth and partnerships at Silence. Been with the firm since January 2024. Before that, I had a stint with Stater, which is a liquid staking protocol. Some of you might be familiar. And before that, I have spent my time in TradFi and strategy consulting, both on the market side and IB side in TradFi.
Over to you, Pulkit.
So from my side, I'm Pulkit. I am a senior engineer working on Okto for the past 3 years, and I'm working on integrating DWN for the past 6 months. My journey at Okto or Coin had basically started around 3 years ago when I won a hackathon Unfold, and after that, that was the time when my main interest in Web3 world that grew, and to explore, to learn more, I joined here, and it has been a fantastic journey. So I'm excited to share what we have built here and to discuss more on that part.
Amazing. So let's kick things off with some grounding context. This is like an open-ended question to both of you. Can you give us like a elevator pitch for on what is development and how NPC implementation really means for the average Octo users, and why should they really care about it?
Sure, Pulkit.
Sure.
Maybe
I think,
I can go first, and then you can add.
yeah, sure.
Right. So from an MPC perspective, I think the main thing that you should care about is the decentralization of their private key. I think generally, a lot of users are in the Web3 segment or are sort of Web3 native because they do care about decentralization and not having a single point of failure, and which is exactly the problem that MPC solves. And with this sort of DWN network, we're taking it one step further by having the shards also distributed amongst different participants, right? So that's the kind of elevator pitch.
Pulkit, would you like to
Yeah, I
add
would
any?
say yeah, so the security that DWN plus MPC provides, obviously, the no single party is able to access user's wallet. So that's the main security benefit because it's a decentralized wallet network. Then Okto combined with DWN, that kind of provides like a unified and a simplified experience to users. User does not have to worry about different chain. Okto abstracts all that, so user is able to see and use his assets from different chains in Okto itself. Also, users do not have to worry about remembering seed phrase or different passwords to access wallet using the auth layer, another implementation of MPC provided by Silence Lab. We are able to log in using the familiar Web2 style methods like Google or Facebook, and user can access his wallet then. So Okto with EWM, it is able to simplify all the complexities which existed in Web3 world and were a hindrance for users to onboard into Web3. So I think yeah, like that's the main pitch. I would say that which is there for average of the user.
Awesome. And Pulkit, what specific limitations or pain points in current wallets that led us to partner with Silence Labs in the on this MPC solution? Would you like to say anything about that?
Yeah, so MPC normally is like a multi-party computation. So that allows multiple parties to come and sign, and only after that an order would get passed. But these parties, they are not on a decentralized network right now. So, like previously, also there was when we were providing a Okto wallet, one of the node was on user's device and two of the nodes with us, so that there is no like security was there that no single party has access to user's wallet. But that also means that if Okto goes down or if user loses his device, then he loses the access to his wallet. What Silence Lab provided with DWN, which is decentralized wallet network, was that now there are multiple operators having like computing and making sure that there's a quorum there which exists there. And even if one operator or even if they are like in a, as long as n by two, less than n by two operators, even if they go malicious or they are not able to respond, the wallet, the access to funds, everything will still remain there. So that's the main security benefit which comes there. That is a decentralized approach that is now available to us. Apart from that, another functionality which was provided was the delegated access, the ephemeral keys or secret keys. These are the features which were not present previously in the MPC part. Now, using delegated access, uh, like user can just give permission to vendors or the clients that this is these are the funds that you can use to access my wallet, and these are the limitations. And even if user is not then available, the vendor on behalf of user can execute those transactions until a certain limit. So all these functionalities, all these features, a secured way, which were not present before in MPC. Now we are able to provide them to our users.
Thank you for that. So, moving on, Gautam,
Yeah.
what makes the DKLS 23 protocol significantly faster than the others? Can you also share some actual benchmarks or comparative metrics?
Yeah, sure, absolutely, right. So I won't go into the maths of the cryptography because I think that'll be a little bit too much. But in simple terms, MPC, especially for ECDSA, which is sort of elliptical curve cryptography, and that's underlying the Ethereum protocol, it has been sort of dominated by CC GMP algorithms in the past. Now, these algorithms basically had a limitation or sort of a lower performance because there were a large amount of messages being exchanged between the nodes, right? Every message that it gets exchanged between the nodes creates latency, also creates issues or a potential for things to go wrong. What DKLS 23 does, and its previous predecessor DKLS 19 as well, these are what we call oblivious transfer based algorithms versus the more sort of dated Pallier based algorithms. Because in Google that I won't get into the implementation, but basically instead of 8 rounds of communication between the nodes, now there are 3 rounds of communication between the nodes. And with something like a DWN, we can do pre-processing and in some cases bring it even down to 1 or 2 rounds of communication, right? So lesser the round of communications, the faster the algorithm is. And why people should care about it being faster at the scale that say Okto operates, right, and some of our other global partners operate. The scalability and the latency matters a lot because yours is not the only request going through the system, right? So if I talk about DKLS 23, what makes it faster in simple terms is the need for lesser amount of data exchange between the nodes without compromising on cryptographic security. So that's the crux of the protocol. In terms of specific benchmarks, for of course it depends on network latency. So right, how far you put the nodes, you put one node in Costa Rica and the other one in Sweden. Of course, there's going to take some time for the data package to go here there. But in a typical setup where nodes are generally co-located, you can see signature speeds as low as tens of milliseconds, and so this is like 10 to 30 milliseconds, so it's almost imperceptible. And of course, for wallet creation, this will be like 200, 300 milliseconds, right? But of course depends on network latency, but this is kind of like the benchmark that can be reached. So I hope that answers.
Awesome, awesome. And can you also explain how your slashing mechanism works? Like what triggered penalties and how does this create accountability across the node network?
Sure. So I think the slashing, before we move on to how the mechanism work, is important to understand or spend a little bit of time on what are we trying to achieve with the network and the slashing mechanism and the incentive mechanism, which is the other sort of part or side of the coin, right? So when you have different parties running MPC nodes in a network, you need them to behave in a expected manner, right? So like Pulkit mentioned right at the start, the idea is to make the network resilient to malicious actors. And what that means is anybody who's participating in the network should have an incentive for doing the right thing and a disincentive for doing the wrong thing, right? So hence, if the MPC protocol that we've built has an additional feature which is specific for DWN and similar networks like this, which is called identifiable abort. And the idea there is that we can recognize parties which are sending non-expected messages on the network, right? So these non-expected messages could just be errors, or could be attempt at sort of attempt to get to the network to do something that it's not supposed to do, or an attack or something like that, right? So when we look at what we need the operators to do, one is that we need them to be available, right, uptime, and they should respond within a certain SLA. Two, they should behave in an expected manner. Like I said, they should not be sending messages which are not expected from the protocol, which our new feature identifiable abort can identify, right? So hence, if the opposite of any of these two things happen, then we should penalize the operators or the people running the nodes, and hence that's the criteria for slashing. One is, broadly you can call it liveness. The second one is this identifiable abort led thing, which is basically, are you sending the right messages on the network, right? And of course, one will be, within SLA will be a lower kind of crime, so to speak, and one is of course a more serious offense.
Makes sense. So, coming back to DKLS 23,
Yeah.
why did you choose a two of three threshold signing model? What makes it right balance between decentralization, reliability, and operational efficiency?
Yeah, no, great question, right? So I think this again, maybe a 1 minute context on why, what threshold signing is, and why these things are important, and what's the trade-off, right? So technically, DKLS 23 can basically be built for any what we call T cross N network. So you can have 3 comma 5, 5 comma 5, 7 comma 11, 20 comma slash 20 out of 100, whatever you want, right? Potentially it can be scalable to that extent. However, there is a trade-off. The three messages that I mentioned right at the start, they have to be done bilaterally. So the more nodes you have, you're essentially, for the full network, you're creating more messages, you're creating more latency, right? And you're also basically saying that X amount of actors can basically are needed to be live for the transaction to go through, right? So it doesn't make sense to have a 20 comma 20 network, for example, right? Because you're creating too many messages. Okay, you're adding a little bit of decentralization, but that decentralization is probably very minimal as compared to, say, a 7 or a 5 or a 3 kind of system. So that's kind of the context. So the higher you go, the more chances of people not being live or the nodes not being live, and the higher the latency. And the lower you go, obviously, you're sacrificing a certain amount of decentralization. What we have seen, not just with our wallet partners like Okto with the GWN, but also with institutional money, right? We work with BitGo, which is the biggest custodian in the world. We work with a few banks. 2,3 is basically the world standard for this, because this offers decentralization and recovery without without compromising on latency that much. So if you look at people like BitGo, who are like running tens of billions of dollars, right? They're running on a 2,3 system, right? If you look at the best banks who are sort of getting into stable coins, most of them are running on a 2 by 3 system. So going forward, we can, of course, we have dynamic quorum, which is another sort of special feature of DKLS. You can move from 2,3 to 3,4 or 4,4 on the fly without changing the user's address. right? But to start off with, I think 2.3 is a good system. It's kind of the industry practice. It gives you enough decentralization. It gives you redundancy and recovery options without having a single point of failure. And even even with one node being down, you can still do signatures.
Very helpful. So, Pulkit, my next question to you. Uh, how is this MPC infrastructure being integrated into the current wallet architecture? And more specifically, what does this mean for developers building on Okto?
Mhm. So I will take it like one by one. So Octo's MPC infrastructure, like that is deeply integrated into our wallet architecture, primarily through DWN, which act as the backbone for us. And if you see, so DWN is responsible for two main functions. First is to create the wallets, to create users' wallets, uh, in which the private keys is stored basically. And the second part is securely signing the transactions so that no malicious transaction is being signed. And how this is achieved is again combining several different layers. So first layer comes as the auth layer, which itself is our 2 comma 3 MPC. And these three nodes, like 2 comma 3 MPC nodes, so these three nodes, they initially validate that whatever social login a user is doing, maybe it's Google, Twitter, or Facebook, so all of these three nodes will go and verify that that those credentials are correct. Once those credentials are correct, then they come to a quorum that yeah, the Twitter token or the Google ID token which was given, that was correct. This is the user, and now they are able to either create the wallet if it's a new user, or access to a already created wallet. So Auth is the first step you can say, which itself is an MPC that sends the message to DWN to retrieve or create the wallet. Once this is done, after that, whenever us signing is needs to be done, then DWN is able to verify that whatever message is coming, the session key that was registered during the authentication part, the message has been signed by the session key. And after again all the three nodes in DWN, they will verify that the signature is valid. Once all the out of those three nodes, once two nodes have verified that the signature is correct, only then they sign using the actual private key. So you can say that the MPC is kind of deeply integrated in both creating the wallets and signing the transactions. And what this means for developers building on Okto is, first of all, again, the security mechanism, the funds of the user, the access to user's wallet signature, all of that is being secured by a decentralized wallet network, in which which is distributed between three different node operators. And apart from that, the complexities of all these things are abstracted using Okto and DWN. So from the developers' perspective, they get a very friendly SDK, which they can use to integrate our whole ecosystem. And for them, users can just directly come to a social login, and they will be able to get the wallet, which can be used to access Web3 world. So again, the seamless integration and seamless offerings, and just getting away from all the complexities of Web3 world. That's what is the offer for the developers using Okto.
Amazing. So, with this new stack in place, what becomes possible that was not feasible before, either from a user experience or a product innovation standpoint?
I think fundamentally, first thing is the simplifying Web3 interactions. Uh, Previously, users would have to, know their seed phrase, remember those things, store it somewhere safe. But now, using the auth layer MPC, they are able to just log in through their social logins, and all the recovery mechanisms, all the security mechanisms for the logging in, which is already intensively researched by Web2 companies like Google, Facebook. So we are just able to, yeah, utilize the same thing for users' security. So that's the first capability which was not possible before. Then second capability that comes is the delegated signing, in which user can just provide a private key, just generate a private and a public key pair, provide a public key to DWN, and that gets registered as the session key. Now, whenever user is signing a message using that session key up to a specific limits. All those limits we can define that this session key can only access funds up to, let's say, $100. So all those limits, all those security limits, all those whatever conditions we want, we can place those conditions, and using that, once those conditions are satisfied, only then DWN would be signing the transactions. So delegated signing, which was not possible before, now that is possible. The security has been enhanced. It's easier for users to now log in using the social logins. All these functionalities are what which were not possible before we had integrated with DWN.
Great. So this is open ended to both of you. Can you walk me through like a real world transaction flow? Like let's say I'm a user and I hit send in the app. What happens from that moment to final on chain confirmation?
Sure. So I will just take it, and then Gautam can also add on it. So whenever user clicks on the send, user is presented with a very verbose intent. We call it intent, in which he's able to see that uh, this is the amount that he's going to transfer to this recipient from this wallet address. All those things he's able to see, and he signs that using his session key, which we discussed. And the session key is only registered using the authentication of his social login. So it's a very secured keys which only exist on his front end device. Now, once user has signed the this verbose message using his session key, this is sent to the Okto system, which which translate this verbose message to different number of transactions. Now, these are the transactions which will be executed on the destination chains. So, the connecting with different chains and interacting with different chains, all that is also abstracted using the Octo. So, for user or for the client, now they just have to send the transaction, send the intent. Intent gets intent gets divided into different transactions. Then these transactions are sent to DWN for signing. DWN, which already has multiple operators, it securely verifies that the session key signature is available on these transactions. Once this is verified, only after that, all the three operators will sign that, yeah, this is the correct transaction. Now we can sign it using the actual private key of user. So you can see that with this architecture, the actual private key is never leaked either to the client or to the user or to the outer world. It always remains securely divided in an MPC. Once this signature is done, then that transaction is actually executed on the destination chain, maybe Ethereum, Binance, or Phantom, for example. So that's what basically happens from start to end and executing it on the final chain.
Yeah. Maybe I can add a little bit more details around the DWN part, right? So I think what's important for folks to understand what's changed is that each of the participants in the DWN network will basically do an independent check of their authentication and this what the session keys guardrails have been set. This makes it a very very powerful sort of system altogether, because so if you think that one of the infrastructure providers or the validators or the nodes in the DWN has a 1% probability of getting hacked or compromised. Now imagine to actually compromise the whole network, you have to do that twice or thrice, right? So it's a 1% to the power of 2 to the power of 3 in order to take that. So even if there is a mistake or a malicious actor, the idea is that the checks are independently done so that the user funds are doubly and triply secure as compared to a regular setup of a wallet. Yeah, the rest of the things was, I think, Pulkit explained brilliantly. The other important thing is the abstraction, right? Because we wanted to provide, with the help of Okto, this sort of decentralization without compromising on the user experience, which I think is why this partnership makes a lot of sense.
Great, great breakdown. So, Gautam, one major concern with MPC is collusion. How do
Yeah.
you prevent a group of nodes from reconstructing the private key? Like,
Yeah.
what cryptographic guarantees are in place?
Yeah. So I think the There are two parts to this. One, probably too mathematical to explain without a whiteboard, so I'll leave that. But basically, the idea is that using these protocols, and these are battle tested protocols, people have peer reviewed them, there are research articles around them. Using these protocols, you can basically create shards or portions of private keys that can never be sort of uh, combined, or that are given to different people through a way that they can never guess the original private key, right? So that sort of mathematical guarantee, let's just take that as a given right now, in terms of MPC and ECDSA and the DKLS 23. But there are more steps on top of it, right? So one is that each of these shards and the computation that we were talking about in each of the DWN nodes is not taking place on a random server. They're actually taking place inside what we call a TEE or an HSM. So a trusted execution environment. This could be AWS Nitro. This could be GCP's confidential compute. This could be a bare metal SGX sort of setup, right? So it's not that this computation is taking place on a server where people can sort of just do a side channel attack and listen in and what's going on, right? So basically, that is one element. The other element is all the messages that are being sent across between the nodes, they are end to end encrypted, right? So anybody listening into the network also cannot make out what the conversation is going on within the network. Lastly, we do something called key rotation by design within the DKLS 23 protocol. What that means is that basically the keys, the shards that are given to each of the node operators today might be different from the shards that are given, say, 1 week later, right? So it's not like you can sit there and keep on signing and guess what the other folks are doing. The shard that you have is valid today might not be valid 7 days later, and this is a security protocol followed again by some of our institutional clients as well, where they keep on rotating the keys. So it's a layered system. The mathematical guarantees are at the center of it, which is the core promise of DKLS 23 or any other MPC protocol. But there is the TEE layer, there is obviously the key rotation layer, and there also the end-to-end encryption layer for the data which is moving.
Awesome, awesome. And Pulkit, how is Okto approaching key recovery and wallet access in this new MPC based model?
Yeah, so for us, basically the approach to wallet access and key recovery is it gets fundamentally different from traditional single private key wallets, primarily due to the MPC design again. Rather than a single private key that can be lost or compromised, because we have an MPC architecture where there are multiple independent nodes, there is no way for the private key to get leaked completely until unless there's a collusion, which again Gotham has described on that part. But this means that there's no single private key for a user to lose in the conventional sense, and ownership is distributed across a threshold of the operators. Now, in case, even if in the, let's say, edge case where user loses his device or a way to access this DWN or a quorum, then we are also leveraging auth layer, which itself is an MPC to verify social login of users. So user can just do a login using Google, or let's say using Twitter, Facebook, the other social logins that he has initially enabled. After logging through these social logins, he will be able to access his wallets again. So that's the main benefit of kind of separating user authentication from his wallets. And using MPC in both the cases, we are able to secure both the things.
Awesome. And beyond core wallet functionality, what new features or products are you planning to build on this MPC infrastructure?
I think the main benefit of this MPC infrastructure is that different vendors or different entities, they can use the same wallet of user. So our main focus going forward is on the interoperability, in which a single wallet of the user can be used by different entities, so that it should not be like each entity is creating its own wallet for user, and user has to maintain the funds in different wallets just to use any particular function of that entity. And for this part, we also have policies which are inbuilt in the MPC architecture of DWN. We also have a policy engine of our own on top of it, which constrains and puts limits on top of vendors so that a malicious vendor won't be able to drain the entire funds or entire wallet of the user. So interoperability using the same wallet across different vendors and different clients, all these things are the things which we would be focusing upon and making them more robust so that the liquidity can be concentrated instead of it being fragmented into different wallets.
Sounds very good, cool. Um, like this roadmap really opens up a ton of possibilities. So, Gautam, I'd like to ask: Is this MPC network exclusive to Okto, or can other teams and wallets also build on top of it? Like, what's the broader ecosystem play here?
Sure. So I think this again the core MPC or DKRS protocol that we have built, like I said, has been used by institutional players and large players before as well, right? What I would say is what Octo has built with us, and I think it was like Octo's vision, and we helped enable it. Is pretty unique. It's not. I haven't seen another implementation like this. It's not stopping other people from copying it or sort of using similar things to go ahead, but I think it's also difficult to do at this scale, right? It requires a lot of imagination and requires deep understanding of users and what they want and how to execute securely and safely. So technically it's not exclusive or unique, but exclusive technically is not exclusive, but I do feel it's unique in terms of the implementation and the scale of it, right? It's not stopping anybody else from doing something, but I don't think it's a small endeavor also to set this up.
Makes sense. Sounds fair. And also, is this network modular enough to serve builders outside of Octo too? Like, what's the future of interoperability here?
Yeah. So I think I mean, just to answer from a technical point of view, it is modular enough to serve anybody outside Octo as well. Like I said, you can have any T cross N network. You can have this for all the EVM chains. You can have this for Solana. You can have this for native Bitcoin or any other sort of protocol. I think what uh, developers and teams out there that want to execute have to ask themselves is what's the point of recreating what Octo has already created, right? So if you the idea would be it will be much faster to build on top rather than kind of recreate the network because there are network effects to DWN and to use this. Of course, like say DWN uses also uses MPC for auth relay. People want to use MPC for something else, which is a downstream or an upstream process. Yes, you can use that. The tech is modular enough. However, like the idea would be that for core private key management, you would just use DWN and Octo rather than build something yourself.
Awesome. So, this is for both of you. What verticals do you think will benefit most from the stack in the coming years? DeFi or RWA asset, RWA gaming or something else?
Sure. Maybe I can go first, right? So I think a lot of sort of verticals like you described them or use cases can use this like gaming for sure, right? The keys are abstracted away, the latencies sort of fast enough that games can use it, and games can put their own economies on top of it. Given my background in finance, I'm most excited about DeFi, and I would club RWS in this because DeFi has been always had this sort of user interface problem, and anybody who's bridged assets from one chain to the other knows how much of a pain it is. So I am personally most excited about automations that can be built on the DeFi in the DeFi space on top of this. But I do feel that social networks built on top of blockchains or games who are using blockchains to power their economy can also potentially use this.
Yeah, I think I will agree with Gautam here. The main thing I'm excited about are the games because using MPC, DWN, and the abstractions that we have built, the gaming community or the gaming devs, they are able to use delegated access feature through which they even if user is not online up to a certain limit, they are able to access users funds which has been allowed by the user, and use it as they want. So if, for example, if they want to use it for NFT purchase, or if there's any kind of marketplace for which user had placed his in-game items, so all those things are getting now possible. Even if user is not offline, even if user is not online, those things can be done. And definitely because MPC, it hold keys, and these keys, these wallets are on on every chain which is there. So interoperability between different chains is also now possible. So the DeFi products which can come, they can work across different chains, which has been currently limited only to a certain specific chains. But now all these functionalities are are now possible using the DWN and MPC architecture. So just excited to see what new things would be there in the future.
Interesting, very interesting. And do you think as users become more conscious about wallet security, do you think decentralized MPC infrastructure like this will become the new default?
Yeah, I definitely think so. So because the security is the main concern, which has been always been there in Web3 world. Users losing the access to their private keys, or forgetting their seed phrase, writing it down but not knowing where they had written it. So these things were very common. Now once that has been solved, and after that all these different chains coming in, after that abstraction is also done, that they don't have to cater to individual chains. So this will allow them to just focus on building the main applications, and not focus on the where nitty gritty things of Web3 world. So I think, yeah, MPC is here to stay, and even DWN or Thaler, they are just products built on top of MPC. So I'm guessing that MPC will stay here, and new exciting products would be built on top of it.
Yeah. I mean, just to add to what Pulkit was saying, right? I think traditionally there's always been this trade off of whether you want a fully decentralized and secure sort of signing process, which is, the seed phrase sort of process of the world, or do you want to go for a fully centralized exchange, which basically is that you're trusting one party and you're just using your regular Web2 kind of login. One had, obviously the decentralization and security aspect, but a more clunky interface. You had to deal with a lot of change, you had to deal with a lot of signatures, you had to deal with gibberish being signed through MetaMask and all the other wallets, right? And the other side was more, you trust this centralized entity, but you get, a smooth sort of user experience and onboarding. Now I think what we're trying to create together, like Okto and Silence, is a best of both worlds, where you don't compromise on security, but you also get those Okto features where you don't need to worry about different chains, you don't need to worry about having a seed phrase. And I think that's very powerful. And as you know, even as a user, once you get to understand all of this, there is literally no reason for you not to use it.
That's a power. That's a powerful direction, I guess we're headed, and I think we're already starting to see that shift. So, in the next 2 3 years, where uh, where do you see the decentralized wallet infrastructure sort of evolving?
Sure. Maybe I can start with that answer, right? So I think we're already kind of seeing some green shoots of it, right? So the wallet infrastructure, the decentralized wallet infrastructure, is right now not just being used for on-chain transactions. You see a bunch of Web2 companies getting into the stablecoin space. You see Robinhood announcing tokenized stocks, etc. All of these will require wallets at the back end, right? And like we discussed, like decentralized wallets are the right way to go in terms of having security and not having one party being the single point of failure in all of this, right? So I see sort of decentralized wallet infrastructure actually being embedded into what we currently call TradFi very, very deeply, right? Whereas you might, as a user, you might not see it. You might not see that, okay, this is a wallet, but every app that you will interact with probably will use a wallet at the back end. And if you sort of aggregate all of the fintech apps that you interact with, from payment apps to stock stockbroking, through investing, through savings, gold, fixed deposits, etc. I mean, there is a lot and lot that can happen, and we're seeing some green shoots of that. But I definitely think over the next 2 3 years we will cover a lot of ground, and the number of wallets will just explode because of this.
I agree, and I think like if we look at the past, like before 2 to 3 years ago, there were not many traditional companies which were coming into Web3 world because
Right.
the Web3 wallets were so complex, user onboarding was so complex that they had no interest, and they did not even think that maybe blockchain and wallets they will actually be able to go ahead and start the onboarding of user in such a seamless, secure and easy way. But now, because that is now possible, all these traditional banks, traditional companies, all of them have started onboarding to the blockchain world, and they have now started integrating Web3 wallets into their ecosystem. Now, once this starts, a new age of innovation on the Web3 front starts, and the base of all this would be the wallet infrastructure, because a wallet and a secure wallet on top of that would be required for every Web3 or even for every Web2 based company which wants to onboard into Web3. So I think yeah, like the decentralized wallet infrastructure, it will be evolving at a very rapid pace now. Like what we had seen in the past 2 to 3 years, what we would be seeing in future would be much faster now.
I mean, yeah, that's 100% aligned there. So, towards the end, there's this one final question that I have for both of you. What's one underappreciated or exciting aspect of this implementation that we haven't discussed yet in this stream?
Sure. Maybe I can go, right. So I think we've discussed a few important things like chain abstraction, like decentralization. I think one thing that probably we haven't discussed is that this is built to last quite a long time, right?
Right.
So the way that this is kind of been built is super modular, like Pulkit was describing the author layer, the DWN, the different components, right? So you can, if tomorrow there's a better technology, if we want a quantum proof algorithm, you can take one portion out and put another in, and it doesn't change the system. It doesn't change what users need to do from an interface perspective and from a workflow perspective. And the other aspect is that tomorrow, if you want to move from a 2 by 3 to a 4 by 5 or any other network, like the MPC protocol is flexible enough to kind of do it. So I think one thing that potentially we haven't discussed and people should keep in mind is that this infrastructure is built to last for decades, and it can be sort of molded and changed based on how new technologies kind of come up in the future.
Yeah, I had the same thing in the mind actually. So the main part here is that the base that we have built, uh, now we can create just apps on top of it. That base will stand there, and that base can be reused because it is something uh, which has been built too long, and it's not something like which will get old in just 1 to 2 years because it can be upgraded, and other things will be built on top of it now. So auth layer is just an example using MPC. DWN is an example of using the MPC. Apart from that, what I think is that we had mostly discussed other aspects, but the important things are that the features which I would again want to highlight would be the delegated signing and the interoperability part that we would be going forward. These are some things which were not possible before, but now using DWN and the MPC part, we are able to go ahead and implement those things. So I think like this would be something until unless it's out in the market, it will always be underappreciated until users start using it.
That's super clear. All right. With that, we wrap up our this episode of the abstract. Huge thank you to Gautam and Pulkit for joining us and sharing the thinking behind the tech. And everyone who tuned in, a big thank you to all of you. We're excited for what this means to the users and the future of wallets in general. More to come soon. Thanks for tuning in.
Thank you.
Thank
Thank
you.
you.